All right, we're going to start our review for the last uh, um, exam we take this calendar year. It's been a pleasure, so we're going to start covering a few things that you need to start taking notes on. Not everything is on our worksheet, but I will make sure that you are aware of what you are responsible for. The first thing is how to be successful. Well, in Chapter 7, we need to know the polygon interior angles theorem. That tells us how many degrees are within a polygon that's convex. And in this case, it is a formula, n minus 2 times 180 degrees, n being the sides of the polygon. So this one you need to put on your notes because you'll need it. And it gives us the total degrees. The next one is the exterior angles theorem for a polygon. Again, we're using the number of sides of the polygon, and then know that all of the sum of the exterior angles that are drawn in is equal to 360. Now we get to the parallel opposite side theorem. The parallel opposite side theorem has two sets of parallel lines with two sets of congruent sides. You can tell by the little red gashes around that item, the parallelogram. We also have opposite angles theorem for a parallelogram, and it says opposite angles are congruent. The next thing is something that is a parallelogram but has some unique features. It is a rhombus. In a rhombus, the diagonals are perpendicular. That means they create 90-degree angles where the diagonals intersect. So this one's going to be used in one of the problems that you'll have. Then we also have this idea, which happens for the parallelogram as well as a rhombus, and that is that the diagonals bisect the vertices, the angle vertices of the polygon, so that makes congruent angles. The next two on Chapter 7 are specific, and they are the isosceles trapezoid base angle theorem and the trapezoid mid-segment theorem. These two theorems tells us that if it is isosceles, meaning that two sides are congruent to the parallel lines that are in a trapezoid, then the base angles and the top angles are congruent to each other. The trapezoid mid-segment theorem is one for computation. It says that if we have a mid-segment that bisects both of the sides of that trapezoid, then we have the mid-segment being the average of the two exterior segments, the parallel lines. Okay, now we're in Chapter 8. Chapter 8 was about similarity and proportionality. Proportionality is a ratio, and this ratio happens to be from one polygon to another, and it makes a fraction. So in the concept of perimeters, the perimeters are proportional, so that you can find the missing one if you have one complete information on the other. Notice that we have, in this case, KLMN quadrilateral, similar to PQRS quadrilateral. So we add up all of the edges, and then we come up with a particular relationship, so that we have PQ and KL are proportional to the totals of each one. Then we have the area. Now the area has to have the side squared. So in this case, we have that particular theorem. Now the rest are kind of make sense. If two triangles, now these are in triangles only, if two triangles are similar, then two angles have to be congruent. You don't have to worry about the third one because it's automatic. Then we have side, side, side. That means that each side is proportional to the pair of the other side proportionality. Side angle side says just what it is, that if we have one side is proportional to the one on the next triangle, is proportional to another one that's enclosed by an angle that are congruent, then we have side, 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 or side, side, angle. Now, this one is very unique. It causes proportionality. It says, and I'm sorry, my pen just went a little crazy. What this one does is says, if we have a bisecting of one of the angles, and we know that the two sides of that bisector are congruent, but what is more important is that the relationships of proportionality exist on the sides. In other words, AD in relationship to BD as a proportion is equal to CA to CB. So these two can then figure out what's missing in that triangle. It's a good little theorem. Triangle proportionality theorem says that if we have a line that's parallel to the base of a triangle, then we're proportional. It divides it into two proportional items. Notice that we have RT in red is to TQ on the same side as RU is to US. Well, let's get to some examples. All right. Our first example is, of course, from chapter 7. And in this one, we're wanting to find the degree of the unknown angle within the polygon. It is a polygon. So our first step is to find the number of sides. So I'm gonna count them. 1, 2, 3, 4, 5, 6. All right. So we've got 6. Now I'm going to structure the problem by using our formula. Polygon, which is n minus 2 times the 180. Okay, so I have 6 minus the 2 times the 180 degrees, 720 degrees. So, now that I have that, I can now structure my problem. 720 degrees has to be the sum of all of the angles. 102, 146, 120, 124, and 158, and our unknown x degrees. Let's add up these guys. And when we do that, we get 650. And double verify. Okay, in other words, strike those keys. I'm going to subtract 650, and I get 70 degrees for x. Now this one did not print out on my sheet. I doubled the first one. So please draw this one, label, and we're going to work it together. I'll give you a few seconds, a few minutes. And I'm going to see if I can get a blue going. Yep, got it. All right. So on this one, we know exterior angles to a polygon equal 360 degrees. So now we're going to structure this problem. So we're going to have that 360 degrees has to equal the 50 degrees plus 48 plus 59 plus x plus x plus 58 plus 39. Okay, we're going to add all of the degrees that we have. My calculator's coming up. Right? So I'm going to add, I'm going to start with the 58, and then the 39, and then the 50, 48, 9. Okay. And I'm making sure I didn't make a bobo there. 254. And I have 2x degrees. I'm going to subtract it from that 360 and get 6. Now, I know my calculator says negative, but I just didn't want to type it all in. I'm going to divide by 2. I get 53 degrees. All right. Moving along, we have on this one the use of parallel opposite angles theorem and the parallel opposite side theorem. And we're going to structure this little problem, nothing hard. Has to equal 63 degrees by the theorem. And then we have 7 has to equal 16 minus h. So I have two little problems to do. I'm going to subtract 4. I get 59. It is not a degree. It is a portion of how to get the degree for that particular corner. So here I can either subtract 16 or I can add h. So I'm going to add h to make it positive. Then subtract the 7. And h is 9. That uses the two theorems that you should be familiar with. We have a kite. And the kite is very important in doing mathematics. It has properties, and it has 2 angles given, but 2 that are not given. And we notice they're enclosed by equal sides. So these are congruent. Therefore, we can state, because it's a quadrilateral, and we're going to get 360 degrees from that map. And then we're going to take that 360 degrees and subtract the angles we know. We know it's going to be twice the remaining angle. So when we do that math, I end up with 162. So x is 81 degrees. Right. Now, this next one, I have, of course, your instructor has a typo, and please make the appropriate correction on your page. And I think I left off some. This is a 7. And I think everything else is the same. 7, 4, 4, and then, and P, and I think it's correct. I think. All right. So we've got a parallelogram. All right. That means opposite sides are congruent. So I'm going to draw it. And remember, it's M, N, P, Q when you write it out. So now MQ, which is a side one, is 4x plus 7. QP is 6y minus 6. NP is 4y plus 4. And MN is 4. Are both of them 4y plus 10? Oh, wait a minute. MQ. It's all messed up. I'm just not going to do it. I did a typo, and I can't correct it without making a bigger mess. All right. But you will have one where you make both sides congruent. MQ is a parallelogram. That means opposite sides congruent and have the diagonals, which means they bisect the angles. And they want to find MQ. All right. Okay. So we know diagonals bisect. All right. So we know that QP is congruent to PM. And we know that MQ, going to be QP plus PM. All right. So we want this value. So it's going to be 8 and 2/10 plus 8 and 2/10. MQ is 16 and 4/10. All the rest were sundries because they didn't ask us about that. But on the exam, you might be asked, well, what is, if the angle L is 100 degrees, what are the angles of MLN and NLQ? And you can do that because it's the same. Now, this one is using that same two theorems again regarding angles of a parallelogram. And so we know that x degrees is going to be 114. Opposite angles congruent. I almost made a mistake, I'm sorry. And y degrees is going to be 66 degrees. Order is important. Now, we're not going to get that kind of a problem on our test, but we'll get something like this one, because this one uses those two rules in its form. Here we go. Find the value of x and y that make the quadrilateral a parallelogram. So we're doing the converse. In other words, proving that they're congruent in order to prove that it is a parallelogram. All right. So I have opposite sides. So we're going to go 4x plus 13 has to equal 5x minus 12. All right. Now, when I printed these guys out, and I made them kind of small so I wouldn't use a whole lot of paper, some of the signs may not be clear. Make sure that it's plus plus on the top and minus minus on the bottom. So I'm going to subtract 4x. Then I'm going to add 12. So I have my first value. Then I'm going to do the next one, which is this group right here. On this one, I have 3x minus 8 has to equal 4y plus 7. Well, I'm going to use what I've learned about the value of x. I'm going to do some math, nothing major, and you have a calculator. Now, understand, I cannot supply calculators at the time of the exam. So all of mine have disappeared, or nearly. And I don't want to disappoint anyone. So I'm going to subtract 7. Therefore, y is 4. So I have both conditions, the x and the y. All right, here we go with this one. This one has to do with the numbered angles of a rhombus. Now, we're finding all of the angles given what we're seeing. We know it's a rhombus. So we know that opposite angles are congruent. G is congruent to angle E. And we also know that in this consideration, we know that the diagonals are bisectors. So if we have one that's 27, then the measure of angle 1 is also 27 degrees. The measure of angle 2 is 27 degrees. The measure of angle 4 is 27 degrees. Now we know that by what was given, that we have angle FEG as 27. So if we know that, then we know that the measure of angle 3 is 90 degrees by definition of rhombus. Covered that at the beginning of this lesson. So we've got 90 for that guy. Well, if I have 90 and 27, 90 here, then 90 minus 27 has to equal the measure of angle 5. So when I do the math on this, I think I get 63 degrees. Yes, make sure, double check me. And since the measure of angle 5 is 63, then the measure of angle 6 is also 63 degrees. Not hard, just, take your time. So here we are with similarity. Now, similarity is saying that the proportions are the same. So we're going to start with CB is to VT, the longest. And we're going to say that's 32 is to 24. I'm going to reduce that by 8, and I get 4/3. Okay, well then the next larger is the 20 and the 15. So that is AC is to TU, and I'm going to have 20 is to 15. I'm going to reduce by 5 and get 4/3. So far, good. Okay, now we do the last one, the smallest side, which is AB is to VT. I'm sorry, VU. And that's going to be 18 is to 14. All right, I'm going to divide by 2, and I get a 9 and a 7. And not similar. All right, now we have this guy with the test of the angles. In similar triangles, all pair angles so we notice that we have 25, that we have the measure of angle C is congruent to the measure of angle U. Now we have to determine the remaining angle. So I'm going to do this triangle first. So I have 180 minus the 82 and minus the 25 to figure out the third one. So I'm going to use my calculator. And I get, oops, sorry, an entry error. Bad one. That's 82. Sorry about that. I get 73. All right. Because these two angles are the same, we can state then that the measure of angle E is congruent to the measure of angle T. And uh, by the theorem that two angles congruent, then triangle CDE is similar to triangle STU. And again, the symbol for similar is that. All right, right along. So we want to find the perimeter. Oh, uh, I couldn't do it because I did a typo on that one. We're going to find CD. And this is a parallel line drawn on a trapezoid. Drawn on a trapezoid. So this means that I can apply that MN is equal to 1/2 the sum of DC or CD plus AB. All right, because I have what I need. I have 1 8/10 equals 1/2 of the CD, which I need, and I'm given that. I'm going to multiply by 2 to get rid of the fraction. Therefore, CD is 3. All right, nothing hard. Here we have, given the most specific name of the quadrilateral, explain your reasoning. Okay, we've got base angles congruent on a trapezoid. Therefore, this must be 65 degrees, and this is isosceles trapezoid. Here, it's an isosceles trapezoid. All right, here we have um, determine whether they are similar again. Again, when I copied this down, it's kind of getting a little bit mixed up. Please follow along on your page. You all have these, so it's not going to be an issue. Did I miss any? No, not yet. No, I'm at the bottom on this. Okay, on similar, we're talking proportionality. In proportionality, and I think I did this one. Yes, I did that one. Yep, I'm here on this guy right here. We're not going to do this one because, again, there's too many typos on that. We're going to find the width. All right, we're going to name it X. They are similar. So because they're similar, we can set a proportion. And our proportion is 104 is to 8 as the given. I'm going to reduce this. This becomes 13 over 1. 13 over 1 must be congruent to our x over 6. I'm going to cross multiply by 6. And I get 78 is x. And this is in meters. All right. Now, this is more of what you'll get. And this is given that something is similar. And then finding what the value of x is. Now, we don't want to do FOIL. And so we're going to take what's given. We know that 5 is proportional to 10, which is 1/2. Now we can state the 1/2 is got to be equal to, and I'm going to do my 2x minus 1 is to 14. Is everybody comfortable with that? All right, I cross multiply. Now, the only thing that can mess you up is messing up on FOIL. Again, make sure that you copy all the signs correctly because they may not print out as well as I wanted. So there we have, I'm going to add 2. I'm going to divide by 4. Sorry. So I've got 4 is equal to x. And now we're going to test it because it has to be that 11 over 5 times 4 plus 2 has to equal 1/2. And I get 11 over 22. And this is true. So x has to be 4 to be true. All right, now I'm still on 8, and here we go. The length of AB. The length of AB. Now this says, this is on a perpendicular drawn to a triangle. The sides are proportional. In other words, AB is to BC as ED is to DC. All right, so I'm going to have my x is to 3 as 12 is to 4. I'm going to cross multiply. A little bit math, nothing serious. And I get x is 9. So to be proportional, according to the theorem, that's what would take place. All right. Now we're going on the converse to prove that they are parallel. And this is to test proportionality. To test this proportionality, we structure the pieces like we did before to find the missing value. We're going backwards. 22 and 5/10 over 25 has to be the same as 18 over 20. And we're going to use cross multiply to make sure that they are the same. So I'm going to have 22.5 times the 20 and compare it to 25 times the 18. Now it's a matter of calculator. I get therefore Km is parallel to Jn by the converse of parallel lines on a triangle. Very good. So right now, we're getting to this final example that because we're going to stop there and do trig on Wednesday. I have proportionality. It says they are parallel, that PQ and RS are parallel. So this means I can have 2x plus 4 is to 5 as 3x plus 5 is to 7. Does everybody see? I started and ended where I wanted on the proportionalities. I'm going to cross multiply. I'm going to subtract the 14x's. I'm going to subtract the 25. All right. Now I have the first two chapters that I've reviewed are clear-cut definition application. There's no real proofs other than naming possibly what kind of theorem we applied and getting familiar with that. Tomorrow, you're going to do an activity that supports the math on this. It may be easier or maybe a little bit more math involved. Either way, you must work on this. This is your final. It could make or break you. So please, please, please take time to review your notes, use your notes, and succeed. Thank you for listening. I'll see you soon. Bye.